Hello and welcome to another Math with Miss V video. We're still in geometry and we're still working on area and other geometric related things. So in this video, we will look at how to find the area of composite figures. We're still in standard 7G6. And we are looking to solve real-world mathematical problems involving area. So let's start about what's a composite figure. A composite figure is a 2D or 3D shape made of more than one shape put together. So you can see in my examples here, I have a 2D shape that is composite. It's part square, part circle. And then I have a 3D shape that's composite. It's part rectangular prism, part pyramid. Because today we're working with area, we will focus on 2D shapes. So there are three formulas we will be using. The formula for parallelogram, which can also be used for rectangles and squares, because rectangles and squares are types of parallelograms. We're going to use our triangle area formula and our area formula of circle. If you need more information on circles, I will link that in the description box below. So let's just go ahead and get right started with some examples. So our first example here to find the area of a composite figure has a rectangle paired with a triangle. So remember that the area of a rectangle is base times height. So we can see our base is 12 inches. Our height is 10 inches. So the area of this rectangle is 120 inches squared. Let's move on to the triangle. Remember that the area of a triangle is 1/2 times the base times the height. You always look for where your lines are intersecting and form a right angle to determine the base and the height. So my base is 10 inches. My height is 8 times 1/2. So 1/2 of 10 is 5. 10 times 8 is 40. So the area of my triangle is 40 inches squared. And I simply add them together to get the total area of the composite figure. So 120 plus 40 gives me 160 inches squared for the area of this composite figure. Let's look at another example. This time I can see I have a square combined with a half circle. So let's start by finding the area of a square. So a square is a type of parallelogram. So area will be base times height. Squares have all the same measure, so it'll be 9 times 9, which gives me 81. So the area of my square is 81 meters. Now I have to deal with this half circle or semicircle. So if we remember, the area for a circle is pi times the radius squared. What's special here is I don't have a whole circle. I have half a circle. So to get half a circle, I'm then going to multiply times 1/2. Okay? So I can see that my circle is the same width as my square. That means this 9 is my diameter. I need the radius, and I find the radius by dividing the diameter in half. So 9 divided by 2 gives me 4.5. So I'm going to do pi times 4.5 times squared times 1/2. So this is a little bit more complex number-wise, but that's why we have our trusty calculators. So 4.5 squared gives us 20.25. We're going to use 3.14 for pi. And I'm going to change my 1/2 into 0.5 so that I'm working with only decimals. So 3.14 times 20.25 gives me 63.585 times 0.5 gives me 31.7925. Now for ease, I'm going to round this to do 2 decimal places. So the area of my circle is 31.79 meters squared. To find the total combined area, I'm going to say 81 plus 31.79. Put my zeros here. 9, 7, 2, 11. So my total area is 112.79 meters squared. Okay, so we have one more example I want to look at. And this is still considered composite, but instead of combining 2 shapes, I've cut a circle out of my square. So rather than adding them together, at the end I'll subtract them. So let's start with finding the area of my square, which is base times height. I can see that it's 17 yards. So that's not a 17 though. Give me just a second and I will erase that. So 17 times 17 gives me an area of 289 yards squared. Now I find the area of my circle. Sorry, I'm used to a writing system that has an undo button, so I'm adjusting. That equals pi times the radius squared. So I can see my circle touches either side of my square. That means that this 17 yards is my diameter of my circle. So I'm just going to draw that in, and it's 17 yards. Remember, I need my radius, which is half of my circle. So 17 divided by 2 will give me 8.5. So my radius is 8.5. And we're going to say pi times 8.5 squared. When I multiply all of that, I get 200. Whoops, good grief. I apologize for the careless errors I am making in this video, but I believe in students seeing teachers being humans and not always being perfect, so I'm going to leave them. So the area of my circle is yards 226.865 yards squared. Now, because the circle has been cut out, as I said earlier, we're going to subtract. And I'm actually going to round at the end rather than in the middle, like I did on the last one. That becomes an 8, 10, but we're borrowing, it's 9, 10, but we're borrowing, it's 9, 10. 5 minus 10, 10 minus 5 is 5, 9 minus 6 is 3, 9 minus 8 is 1, 8 minus 6 is 2, 8 minus 2 is 6, 2 minus 2 is 0. So I find that the area left over after I cut a circle out is 62.135, which let's round to 62.14 yards squared. And that's how you can use area formulas to find the area of composite 2D figures. Thank you for joining this Math with Miss B, and I look forward to seeing you in the future.